Imagine a cosmic phenomenon so powerful it can bend the very fabric of space-time and light itself. This is not a scene from a science fiction movie, but an everyday occurrence in our universe known as gravitational lensing. Gravitational lensing, a term that might sound like it's straight out of a sci-fi novel, is actually a real and fascinating aspect of our universe. But what exactly is it? Simply put, it's the universe's own magnifying glass. It's a process where the path of light is altered, not by a physical lens made of glass or plastic, but by the immense gravitational pull of massive celestial bodies like galaxies and black holes. Picture this, a beam of light traveling through space. According to the theories of Newton, this light would travel in a straight line, uninterrupted until it hits an object or dissipates into the void. However, in the early 20th century, a certain physicist named Albert Einstein came along and turned this concept on its head. Einstein, through his groundbreaking theory of relativity, proposed that space and time are intertwined in a four-dimensional fabric known as spacetime. He suggested that massive objects don't just pull other objects towards them, they also warp the spacetime around them. This warping, he theorized, could bend the path of light, causing it to curve around massive objects, much like water flowing around a stone in a stream. This is the essence of gravitational lensing. When the light from distant stars and galaxies passes close to a massive object on its way to us, its path is bent, causing the light to magnify and distort. This effect allows us to observe galaxies and stars that would otherwise be too faint or too distant to see. So with this understanding of gravitational lensing, we are set to embark on a journey that will take us to the edges of our understanding of the universe. We'll uncover the role of this cosmic spectacle in detecting dark matter, spotting exoplanets, and even providing insights into the expansion of the universe itself. So let's dive into this cosmic spectacle and explore 10 mind-blowing facts about gravitational lensing. Did you know that the gravity of a massive object can bend light around it, creating multiple images of the same source? This fascinating occurrence is known as gravitational lensing, a phenomenon that can create a cosmic mirage. Think of it like this: a distant star shoots its light into the universe. That light travels uninterrupted until it encounters a massive object like a galaxy or a black hole. The gravity of this object is so strong it warps the space around it, causing the light to bend and curve. As this light reaches us, it paints a picture of not one, but multiple images of the same star. It's like seeing several mirages of the same oasis in a desert. A perfect example of this is the Einstein cross, where a single quasar appears as four distinct images. This cosmic mirage is just the beginning of what gravitational lensing can do. Gravitational lensing can also warp time, allowing us to see into the past. Now, that's a sentence to make anyone's head spin, right? But let's unravel it together. Picture this. Light, the fastest thing in the universe, is traveling towards us from a far-off galaxy. This journey isn't a quick one. In fact, it's so long that by the time the light reaches us, the galaxy it came from has aged billions of years. But here's where it gets really interesting. That light, it's like a time capsule, preserving the image of the galaxy as it was when the light first started its journey. So when we observe this light, we're not just seeing a distant galaxy, we're seeing a distant galaxy as it was billions of years ago. We're peeking into the universe's past. Now, enter gravitational lensing. This cosmic phenomenon does more than just bend and magnify light. It can also magnify this time warp effect. How, you ask? Well, the more a beam of light is bent by gravity, the longer its path becomes. And the longer the path, the older the image we see at the end of it. So, through gravitational lensing, we can observe galaxies even further away and therefore even further back in time. It's like having a telescope that also works as a time machine. Imagine being able to see the universe as it was just after the Big Bang, or witness the birth of the first stars. This isn't just speculation or science fiction. It's a real possibility, thanks to gravitational lensing. The universe is vast and mysterious, filled with galaxies and stars that are billions of years old. And while we can't physically travel back in time, gravitational lensing provides us with the next best thing. Through gravitational lensing, we're not just space explorers, but also time travelers. So, buckle up, because with gravitational lensing, we're not just journeying to the furthest corners of the cosmos, we're journeying back to the dawn of time itself. Gravitational lensing is our best tool to detect dark matter. Now, you might wonder, how can we observe something that's invisible? Well, that's the beauty of gravitational lensing. It's like a cosmic detective, sleuthing out clues about the elusive dark matter that makes up approximately 85% of the universe's matter. Imagine a city at night. The buildings are dark, but the streetlights cast shadows that reveal their shapes. Similarly, gravitational lensing allows us to map the distribution of dark matter in the universe. It does this by observing the way light from distant galaxies bends around these unseen masses. The more the light bends, the more dark matter is present. So while we can't see dark matter directly, we can observe its influence on the light from distant galaxies. In this way, gravitational lensing helps us see the unseen to map the dark matter that permeates our universe. So, gravitational lensing is like our cosmic flashlight, illuminating the mysteries of dark matter. Gravitational lensing has also helped us discover exoplanets. This fascinating application of lensing opens up a window to distant worlds orbiting stars far beyond our reach. Picture this: a star's light journeying through the cosmos gets bent and amplified by the gravitational field of a massive object. This creates a magnifying effect, much like a cosmic telescope. Now imagine an exoplanet, a world outside our solar system, orbiting this distant star. As it moves, it causes slight variations in the star's light, like tiny dips in brightness. These minute changes, otherwise lost in the vastness of space, are amplified by gravitational lensing. This allows our telescopes to detect these far-off worlds, even those located thousands of light-years away. Our knowledge of the universe has been vastly expanded by this cosmic magnifying glass. We've discovered exoplanets with conditions ranging from molten lava worlds to icy gas giants. Thanks to gravitational lensing, we're finding new worlds beyond our solar system. Gravitational lensing happens on a truly cosmic scale. Imagine a cosmic dance where light and gravity twirl in unison, choreographed by the most massive objects in the universe. It's a ballet that unfolds across billions of light years, with galaxies and clusters of galaxies playing the lead roles. These immense cosmic bodies warp the very fabric of space-time around them, creating a gravitational field so strong that it bends light itself. It's akin to a giant cosmic magnifying glass, distorting and amplifying the light from objects located billions of light-years away. In this grand theater of the cosmos, even the most distant galaxies, which would otherwise be faint wisps of light, are magnified and distorted into arcs and rings of light, often referred to as Einstein rings. This allows us to observe these distant galaxies and stars in much greater detail than would otherwise be possible. On a smaller scale, gravitational lensing can also reveal the presence of exoplanets orbiting distant stars, and even provide clues about the mysterious dark matter that permeates our universe. But we must remember that all this happens on a scale that's almost impossible for us to truly comprehend. The distances involved are so vast, the objects so large, and the forces at play so powerful that they defy our everyday understanding. Gravitational lensing truly shows us the grand scale of the universe. It reminds us of our place in the cosmos and humbles us with the realization of just how vast and wondrous it really is. Gravitational lensing can magnify distant objects, acting like a natural telescope. Now, isn't that an incredible notion? Imagine gazing up at the night sky and seeing not just the stars and galaxies as they appear to the naked eye, but their magnified versions, brought into sharp focus by the universe's own magnifying glass. This is precisely the phenomenon at play when we talk about gravitational lensing. The gravity of massive cosmic objects like galaxies and black holes bends the path of light traveling from distant celestial bodies. This bending of light can result in multiple, highly magnified images of the same distant object. Think of it as a cosmic kaleidoscope, offering us a multiplied view of the universe's hidden gems. This magnification allows us to observe in detail galaxies that would otherwise be too faint and too far away to study. We can examine their structure, their composition, their motion, and even their history. Moreover, this magnification effect isn't just about making distant galaxies appear larger. It also brightens them, giving us a clearer, more detailed view. It's like turning up the brightness on a dimly lit image, revealing details previously shrouded in the darkness of space. So, the next time you find yourself gazing up at the night sky, remember this incredible cosmic phenomenon. With gravitational lensing, the universe itself becomes our telescope. Gravitational lensing can also help us measure the expansion rate of the universe. Now you might wonder, how is that possible? Well, let's dive into it. Gravitational lensing can be used to measure the Hubble constant, a key parameter in cosmology. Named after Edwin Hubble, the man who discovered the universe is expanding. This constant measures how fast the universe is expanding at different distances from us. So, how does lensing come into play? When light from a distant object passes a massive object, it is bent and distorted. By observing this distortion, we can determine the mass of the intervening object. This allows us to measure distances in the universe, and by extension, the Hubble constant. This is a significant contribution to our understanding of the universe. It's like having a cosmic speedometer telling us how fast the universe is expanding at different points. Gravitational lensing is not just a spectacle, but also a vital tool in cosmology. The study of gravitational lensing is still in its infancy, and its potential is vast. This is a realm of exploration where we're just starting to understand the magnificence of the cosmos. But as we stand on the edge of this new frontier, we're already gearing up for the next big leap into the unknown. One of the most promising ventures on the horizon is the Euclid space mission. Spearheaded by the European Space Agency, Euclid is set to launch in the mid-2020s. Its mission: to map the geometry of the universe on the grandest scale ever attempted. Euclid will use gravitational lensing as its primary tool, allowing it to peer back over 10 billion years into the past. This will provide us with a detailed snapshot of the cosmic web, the large-scale structure of the universe, and help us understand the mysterious dark matter and dark energy. Meanwhile, on the ground, we're building the Large Synoptic Survey Telescope, or LSST for short. Situated in the Chilean Andes, this incredible machine is expected to see first light in the late 2020s. The LSST will scan the sky every few nights, creating a movie of the universe in unprecedented detail. This will allow us to detect subtle changes caused by gravitational lensing and other phenomena, opening up new avenues of discovery. Beyond these projects, who knows what the future may hold? Perhaps we'll develop new technologies that allow us to detect gravitational waves directly, or maybe we'll discover entirely new phenomena that we can't even imagine today. The universe is a vast, complex, and endlessly fascinating place. And with each new discovery, we're reminded of just how much there is still to learn. As we continue to push the boundaries of our knowledge, we can be sure that gravitational lensing will continue to play a crucial role in our quest to understand the cosmos. The future of gravitational lensing is bright, and who knows what new discoveries await us. Let's quickly recap the amazing facts about gravitational lensing that we've covered today. We opened our eyes to the universe's very own magnifying glass, revealing how light bends around massive objects, creating cosmic mirages. We delved into the tantalizing possibility of time travel, brought to light by the distortions in spacetime. From there, we turned our gaze to the enigmatic dark matter and how gravitational lensing is an invaluable tool in its detection. We also spotlighted the role of lensing in spotting exoplanets and took a deep dive into the cosmic scale, magnifier, and speedometer, all enabled by this phenomenal phenomenon. Peering into the future, we pondered over what gravitational lensing might unravel next. So, next time you look up at the night sky, remember the cosmic spectacle of gravitational lensing unfolding across the universe. Thank you for watching, and keep exploring the cosmos. Before we wrap up, we want to invite you to stay connected with the cosmos. Remember, the universe is not just out there, it's also within us. We are all made of star stuff, as the great Carl Sagan once said. So, let's keep our cosmic curiosity alive, and together, let's continue to unravel the mysteries of our universe. If you learned something new from the video, then please give a like to the video and share your opinions in the comment section. We'd love to hear your thoughts, questions, or any fascinating facts about the universe you'd like to share. Don't forget to subscribe and press the bell icon for more such content, and also share it with your friends and families. This is your portal to the cosmos. and we're thrilled to have you here with us on this cosmic journey. Remember, the universe is always unfolding, and there's always more to discover. So until next time, keep your eyes on the stars and keep exploring the cosmos.